Hi, I'm Anders from Embedded Artist. Do you have a microcontroller-based embedded system and need to start thinking of the next generation? Do you have tough requirements from customers on new functionality? Have you run out of memory or performance of your microcontroller? Have you thought of Linux but are uncertain if it will work for your microcontroller-based application? For example, how to handle real-time requirements? If you answer yes to any of these questions, please continue listening, because in this video I will present how to migrate a microcontroller-based design to an i.MX processor with heterogeneous multicore processing capabilities. Heterogeneous multicore processing is often called HMP for short. By the way, of course it doesn't have to be a migration project. It can be a new project as well, but the angle we have in this video is a migration project. Before we continue, I want to give a quick overview of what HMP means specifically in the i.MX world. Here we see a schematic illustration of an application processor with one or more Cortex-A cores and one or more Cortex-M cores. This is heterogeneous because Cortex-A and M cores are a bit different and optimized for different things. To make a broad but still valid generalization, a Cortex-A core is optimized for high performance and running a feature-rich OS like Linux. It has a memory management unit. It has less focus on power consumption and interrupt latency. A Cortex-M core is a microcontroller core that is optimized for low interrupt latency, power efficiency, and real-time applications in general. This is a system architecture seen on many new i.MX processors. Both sides have access to peripherals and system resources. Now back to the original topic, how to migrate a microcontroller-based design to an i.MX-based design with HMP. There are four basic options. The first and maybe obvious solution is to continue in the microcontroller world. If available, select a higher performing microcontroller and add new functions and features to your existing applications. Continue using an RTOS. Unfortunately, this is often not an option, since you likely have run out of memory and/or performance. Also, supporting complex communication protocol stacks like USB, TCP/IP and different security layers without a feature-rich OS like Linux is difficult and expensive. The second option is to move to the Linux world. Place everything in a Cortex-A core. On the plus side, you get the feature-rich OS. The question is how well your real-time requirements can be handled and how difficult it might be to port your application to run under Linux. Yes, there are real-time versions of Linux. No, they are not just plug-in solutions. You need to dig deep and have full control to make it work. The third solution is to keep your microcontroller design in the existing microcontroller, but add an application processor with one or more Cortex-A cores and run an OS like Linux there. This is an interesting and appealing system architecture. Don't mess with the existing design and place new functions on the Cortex-A/Linux side. It gives plenty of room for future feature growth. The downside is increased cost and more complex hardware. What if both the microcontroller and application processor were on the same chip and had access to basically the same system resources? Then we have an HMP architecture, and that is what many i.MX processors offer. So the fourth and most interesting solution is to use a processor with on-chip HMP architecture. So let me outline a smooth path for migrating your existing microcontroller-based design into a more future-proof solution. Place your existing microcontroller-based application on the Cortex-M core. When I say place, I really mean port. Since this is porting from one microcontroller to another microcontroller and still typically using an RTOS like FreeRTOS, it can be assumed to be a relatively straightforward task with not too many surprises and difficulties. The reuse factor is likely high. The Cortex-M core offers low I/O latency, fast interrupt response time, superior power efficiency and fast system startup time. It boots up quickly, in other words. Let the Cortex-M side continue handling the real-time requirements of your application. Let your application grow on the Linux side. Here you place all your management functions, all the new features your customers want you to add to your project. You can, for example, place advanced graphical user interfaces, databases, file system handling and complex communication protocols there. You can also handle advanced hardware interfaces not commonly found on microcontrollers, like PCI Express, Gigabit Ethernet and MIPI CSI. Let's look at the pros and cons now. Remember that this is from the perspective to migrate a microcontroller-based design to an i.MX processor. There can be other perspectives as well. The benefits are: you can save bill of material cost because you get the Cortex-M core basically for free. The porting work of your existing application can be expected to be relatively simple. You keep full control over real-time requirements and you get separation between critical and non-critical tasks. You get access to a feature-rich OS. You create the future-proof platform. What are the challenges then? Well, the two worlds need to communicate, so some kind of inter-processor communication must be implemented. I will not go into detail about this. That is a topic for another video or even webinar. But there is a framework in place and it's working well. It's called RPMSG. You also need to plan for debugging and get a good task partitioning and separation in the system. None of these issues are unique to HMP. They are common for any system partitioned into multiple execution units. But they get more noticeable if not handled correctly in an HMP system. This was an introduction to the possibilities to migrate a microcontroller-based design to an i.MX processor with HMP Architecture. There are many benefits with this. If you have any questions or want to discuss your next project, don't hesitate to contact us. Thank you for watching.